So mula nung simula banggit na ako ng banggit ng unit operations. Pero ano ba talaga to? Of course, before we go to the definitions, let's look at where this originated. So during the early 1800s, there was the approach of studying processing operations by industry. What does this mean, no? So parang ang nangyayari, if you're looking at today's context, kung gusto mong aralin yung food processing operations, then you study those operations. Kung gusto mo sa petroleum, then dun ka mag-aral, and so on. Unfortunately, this was not really a very efficient way of doing things. So think of it this way. So, paano ba tayo mag-aral ng cooking if you did your FN11 or if you did maybe cooking classes in senior high or in your summer classes, di ba? Hindi ka naman tuturuan by recipe na parang good morning class, today we will learn how to cook adobo. Tomorrow we will learn how to cook caldereta. Hindi ganon. Yung mas magandang approach would be um, tuturuan ka ng knife skills, ganito mag-cut ng julienne, and then tuturuan ka ganito ang frying process, ganito ang bracing or something like that, roasting, so on and so forth. And then when you have a recipe, you just have instructions like, sige, ikat mo ng julienne yung mga gulay, tapos i-deep fry mo under medium heat for 7 minutes on each side, or you brace it for 1 hour at 175 degrees Celsius, etc., etc. So in short, people later on realized na mas madaling aralin yung yung mga industrial processes if you were to break them down into discrete steps. Okay, and kaya nga in 1893, the idea pa lang siya of unit operations popped up. So, na parang basta ganito, imbis na by industry natin tingnan na ganito ang proseso ng paggawa ng gasolina, ganito ang proseso ng paglata ng pagkain. They just broke it down into what individual steps are there and what machineries, for example, are involved in each step. So it was not until 1915 when A.D. Little proposed the term unit operations. Now, yung term na unit ops ay talagang pinakasikat ito sa field ng ChemEng, no? But since as we recognize na ChemEng ay isang heavy influencer ng FoodEng, such that some chemical engineers consider FoodEng to be just a branch nila. So, ayun, ginagamit natin, hinihiram natin itong term na to from them. One of the more simple definitions by G.G. Brown of what unit operations are is that it's simply a unit of a more complex operating plant. So anong ibig sabihin nito? Yun nga, you just break down the whole plant's operations into a series of steps. And the coverage may involve physical, biological, and chemical changes in food. So I've listed here just some cross-section ng mga equipment. This one here is a steam-jacketed kettle. We have a few at the pilot food plant. I do not know if they are still working. So kaya siya steam-jacketed kettle, as you can see. So yung liquid product, you fill it in this cavity. And then meron siyang double-walled stainless steel jacket. Okay, so you allow steam to enter, and it is steam that heats the product through conduction dun sa metal wall, and then the heat from the sides will, through convection, heat up the product. On the other hand, this one is still a heating system but now utilizes a coil. So naka-immerse yung heating coil dun sa loob ng liquid, and then that hollow coil, may steam na dadaan sa loob, lalabas sa kabila, transferring heat in the process as it condenses to hot liquid. Okay, this cross-section naman is a scraped surface heat exchanger. Don't let the complicatedness daunt you. Kung bumibili kayo sa 7-Eleven ng mga Slurpee nila, di ba may makikita kayo doon yung parang may umiikot-ikot na blade na nag-prevent dun sa frozen Slurpee from turning into ice. So parang ganito lang yun. No, it's used for either heating or cooling, and meron lang umiikot dyan. In this case, in cooling, to prevent ice crystals from forming. Okay, this is another heat exchanger. It's a plate heat exchanger, pang-pasteurize halimbawa ng milk or juices. So, what it does is you have heat exchanging plates. Na, so alternately, let's say the odd numbered plates would contain the heating or cooling fluid, and then the even numbered plates, let's say, would contain your food product to be heated. Tapos naka-sandwich yan. And then what the fluid would flow in a somewhat zigzag manner. Okay. And then in that process, so maximize yung surface area ng contact nila to transfer heat, yung mainit lalamig, yung malamig iinit. So one way to identify a unit operation is, of course, kapag nasa planta ka halimbawa, isa siya mismong distinct piece of equipment na merong input at output. So as long as may papasok dyan, may lalabas siya na may pagbabago dun sa kanya, either a temperature change, a change in size, or nag-combine ka ng ingredients together, that would count as a unit operation. So as you can see here, mixing is usually a unit operation for most food products. No, whether you dissolve powders in water or mix powders together or liquids together. So you usually do that in most food production cases. Crushing is size reduction, for example, pero hindi ito madalas gamitin sa pagkain. Usually sa mga bato to like quarry or paggawaan ng semento, ganon. But some of these things na nagawa nyo na, or in theory at least, no, like drying and evaporation, so on. In food processes, let's say pasteurization is a unit operation. You name it, it's a step in the process, it's a unit operation. So yun nga, it may involve just a change in temperature, a heating or a cooling process, no, like yung hardening ng ice cream, or yeah, mostly sa food production, heating and cooling processes siya, and mixing. Pero marami yan, and some of them will even discuss sa mga reporting ninyo. So I'll leave it at that. So we will not be using this notation, wala na tayong oras aralin sila. Pero just to let you know, no, FYI, merong mga, lalo na sa ChemEng, they use symbols to simplify diagrams, no? So we will be using diagrams, pero hindi naman ganitong level. Okay, yung iba dito mukhang pang electronics pa yung itsura, pero just to try and look at it. For example, if they want to denote a pump, they just use this symbol, and then there's that parang check sign to indicate that it's a heating, and then they use a reverse arrow to indicate cooling. So parang, di ba sinasabi natin, visualize food processing operations. So this is one way to do that, na you just saw a number of arrows and lines and shapes on paper, and then you can already think it out in your mind, lay it out on a piece of land, na ito yung mga equipment na gagamitin. Okay? So dahil tayo yung mga critical thinking students, we often question, why do we need to study a certain thing? And as I mentioned earlier sa history ng unit operations, ang nakikita nila nga is napaka-inefficient kasi ng pamamaraan na pag-aralan mo by industry. Ika nga, hindi ka naman magluluto sa magtuturo ng cooking class na day 1 you cook adobo, tomorrow we'll do lechon. No? Again, we just teach each of the unit operations, and then we give them, say, instructions kapag ito yung product mo, what unit operations do you combine and in what order. So yaman din lamang na nag-discuss na tayo nitong unit operations. Maigi na rin na we understand that in unit operations, we quantify everything. So obviously, you have a mass input or a volume input there, and may either kilograms per unit time yon or liters per unit time. And let's say you have a heating or cooling operation, you have a change in temperature, and so on. When you combine mixing ingredients, may ratio yung ingredient A and ingredient B mo, may force yung mixing equipment mo, magko-consume siya ng certain amount of power in watts or joules per second. So lahat yon ay may kinalaman sa units and dimensions. And of course, alam ko yung mga nag-food physics na you've already had your lecture on this with me, but for those who are from the old curriculum, of course, I'm not sure how this was discussed in your Physics 70 series. So mag-review na rin lang tayo, no? When we talk about dimension, it's the qualitative definition of the physical entity, no? Like, ano ibig sabihin ng time? What is a second? How do you define the length? What is a meter? What is a kilogram? And then if you look at the derived units, what is the definition of force and energy, and so on. So in the SI system, we have 7 base SI units. Although typically for, let's say, physics, you use 4 of them, which is length, time, mass, and temperature. So the other 3 are electric current, your mole or amount of substance, and then luminous intensity or candela. Okay, and then secondary dimensions. So primary dimensions sila yung parang ano na 'di ba? Hindi mo na pwedeng i-break down pa. Secondary dimensions naman is a combination of any primary dimension. Let's say area is length times length. Okay, and force is mass times acceleration, where acceleration is length over the square of time, and so on. So the unit, on the other hand, is the magnitude of that dimension. So one dimension could have multiple units, and this is where we have that sobrang iritang unit conversion. Hindi ko alam kung bakit may naimbento pa yung English system at ginagamit pa rin siya ngayon. No, like for example, during our time as children, we were weighed and recorded in, our weight was recorded in pounds. Pero sa panahon ngayon, and in the last few years that I've been teaching food engineering, yung mga students sanay na sila sa weight in kilograms. And then, my dad, who is an engineer, dahil malaki ang influence ng English system sa engineering, sanay sila gumamit ng Fahrenheit. Pero ako ngayon, yung phone ko nag-display siya ng Fahrenheit temperature, and I can't make sense of it until now, and I can't change it to Celsius. So here are just some examples of units and their corresponding dimensions. So yung viscosity, yung mass, alam niyo na yan. Viscosity will be looking at viscosity a lot, especially in fluid flow. So you have Pascal second, centipoise, not centipoise, wag niyo nang ipasosyal yan, centipoise talaga siya. And then a lot of other units for viscosity and even pressure abound. Alright, so I discussed units and dimensions na sa kabilang tawag dito, sa food physics class, but again, we'll do a longer review of it probably for the sake of since old and new curriculum yung kasama natin. Just show you this picture now. This was taken, I don't know, mga 2015 ata, when we were being audited for the IUFOST accreditation ng BSFT curriculum. So that man standing behind me is Dr. Dennis Heldman. He's actually the book author of one of the most popular food engineering books, yung Intro to Food Engineering by Singh and Heldman. R.P. Singh was actually his student before and is now the main author. Good man this person is, sobrang bait niya, no? At grabe, even at his age, I think may 80 years old na siya ngayon, nagtuturo pa rin siya kasi may anak siyang pinapaaral pa. And then amazing, so talagang starstruck kami noon nung na-meet namin siya. That in mind, yun nga, yung main textbook natin would be Introduction to Food Engineering by Singh and Heldman. So I'll be taking some of the problems there. We do have a copy of it in the library, but unfortunately, we can't access it now. But alam ko yung iba sa inyo may mga kakayahan kumuha ng resources. So that's a pretty good book to use. No? Hindi siya masyadong makalculus, but at the same time, na-explain niya yung mga concepts na kailangan natin.